Welcome to TechNova Podcast.
Picture this. You're standing in the absolute pristine, silent vacuum of space. You're just looking down at the gray, cratered surface of the moon, and then suddenly, hurtling out of the blackness right toward you, is a 4-ton, 12-meter-long metal cylinder.
Yeah, just a massive dead piece of machinery, screaming through the dark.
Exactly. And it's moving at like 7 times the speed of sound. There are no brakes, no steering wheel, no mission control team typing frantically on their keyboards to divert it. It is entirely locked in, destined to absolutely slam into the moon this coming Wednesday.
It's just a phenomenal high-stakes image. And the crazy part is, well, it's not a pitch for a sci-fi movie. It's happening right now, literally above our heads as we speak.
Right. So welcome to today's deep dive. We are so glad you're here with us. Today we've got a single incredibly fascinating source that we are dissecting. It's an article hot off the digital presses from the Jerusalem Post, dated today, August 3, 2026. The headline really tells you almost everything you need to know. Basically, a SpaceX Falcon 9 rocket stage is about to crash into the moon and carve out a brand new crater.
It's a spectacular event for sure. But, as we'll see, it is also an incredibly revealing one for the entire aerospace community.
Yeah, so our mission for you today is simple, but it's big. We're going to understand the actual mechanics of this rare collision. We're going to unpack the very surprising scientific opportunity that this crash creates for astronomers all over the world. And maybe most importantly, we're going to explore what this single rogue piece of metal tells us about the rapidly approaching and highly unregulated future of space exploration.
There's a lot to get into.
There really is. Okay, let's unpack this. What exactly is this giant metal cylinder and, how did it find itself on a kamikaze trajectory with the moon?
Well, to understand the trajectory, we have to sort of rewind the clock a bit to the origin of the hardware itself. We are looking at the spent upper stage of a SpaceX Falcon 9 rocket. And this specific rocket, it was launched from the Kennedy Space Center down in Florida back on January 15th, 2025.
Okay, so it's been up there a while, over a year and a half. And rockets don't just launch themselves for fun, right? So it obviously had a primary mission before it became this rogue projectile.
Right. Yeah, it had a very specific and actually highly successful commercial mission. It was carrying 2 privately operated lunar landers. One was called Blue Ghost, which was built by a U.S. company called Firefly, and the other was Resilience.
Oh, the Japanese one.
Exactly, operated by the Japanese company Space. So the Falcon 9's job was basically to get those landers into space, give them the necessary delta V, which is just the push they needed to head toward the moon, and then release them.
And it did that perfectly right.
It did it flawlessly. The landers separated and went on their way, leaving this upper stage, which is essentially a massive empty fuel tank, just drifting in the void.
Okay, but if it finished its job flawlessly over a year ago, shouldn't it have just burned up in Earth's atmosphere? Or at least been pushed into a stable, graveyard orbit? Why is it now, 18 months later, suddenly aiming for the surface of the moon?
That really comes down to the sheer chaos of orbital mechanics in cislunar space.
Cislunar being the area between the Earth and the moon.
Right, exactly. When an object is out that far, it isn't circling the Earth in a neat, predictable ring. It's subjected to this constant, invisible gravitational tug of war. The Earth pulls it, the moon pulls it, and even the sun's gravity, subtly alters its path. It is essentially an n-body physics problem playing out in real life.
It really reminds me of, a game of celestial billiards.
Oh, that's a great way to look at it.
Right, just bouncing around the gravity wells of the Earth, the sun, and the moon. Like you have this empty rocket stage acting as the cue ball, bleeding off momentum, getting pulled a little bit by the Earth, drifting out, getting tugged by the moon. And for 18 months, it's just been spiraling through these invisible forces until it finally got cornered.
Yeah, that visual captures the physics perfectly. The momentum bleeds off, the orbit becomes increasingly erratic, and back in May of this year, the specialists who track space debris noticed that the math had finally run out. The chaotic trajectory had basically resolved into a direct collision course.
Which raises a fascinating logistical question for me.
Yeah.
How do they actually track it? This is a dead tube. There's no transponder pinging a signal back to Earth. There are no blinking lights on it. How do you track a silent, unpowered cylinder tumbling through the blackness of space for a year and a half?
Yeah, it's not easy. You have to rely on optical tracking and albedo, which is essentially the reflectivity of the object. So astronomers and defense networks, they use these incredibly powerful ground-based telescopes to look for sunlight glinting off the white paint of the rocket body.
Just catching a glare, basically.
Exactly. But because it's tumbling, that reflection isn't constant. It creates a light curve, like a flashing pattern that speeds up or slows down depending on how the object is spinning end over end.
Oh, wow.
Yeah. So by measuring those faint rhythmic flashes against the background stars, they can painstakingly calculate its speed, its rotation, and its exact trajectory.
That is wild.
Yeah.
And the numbers they calculated for this collision are just staggering. According to the tracking data in the article, this impact is scheduled for Wednesday, August 5 at 6:35 a.m. UTC. So for those of you listening on the east coast of the U.S., you'll likely be fast asleep because that translates to 2:35 in the morning.
Right. An early morning wake-up call for the moon.
Seriously. And it's aiming near a feature called the Einstein crater on the Earth-facing side of the moon. But the speed is coming in at roughly 8,700 kilometers per hour, which is 2.43 kilometers every single second.
What's fascinating here is the sheer physics of the impact itself, because remember, we're dealing with a dead piece of machinery. There is no fuel left to ignite. There is no explosive charge or warhead on board.
Right. It's essentially an empty aluminum can, albeit a massive 4-ton one, moving at hypersonic speeds.
Exactly, but an empty aluminum can moving at 8,700 kilometers per hour possesses a terrifying amount of kinetic energy. When a 4-ton object hits a solid, rocky surface at that velocity, physics demands that all that kinetic energy has to go somewhere the exact instant it stops.
It can't just disappear.
No, it immediately converts into intense heat and massive shock waves.
Yeah, the article points out that the energy released at that exact millisecond of impact will be equivalent to detonating 3 tons of TNT, 3 tons of explosives, generated purely from the sheer speed of the crash.
It's incredible. The mechanical process of that crater forming is going to be incredibly violent. First, there's the compression phase. The front end of the rocket will hit the lunar soil, the regolith, and the metal will instantly shatter and vaporize under the immense pressure.
Just instantly gone.
Instantly. A shock wave will travel downward into the lunar bedrock, fracturing it, while a simultaneous shock wave travels backward through the length of the rocket, completely obliterating the 12-meter structure in a fraction of a second. Then comes the excavation phase, where all that pulverized rock and metal is violently thrown outward.
And that creates the crater.
Right, a brand new crater that they estimate will be 20 to 30 meters across and about 5 meters deep.
So a crater the size of a basketball court, instantly carved out of the bedrock. But here's the thing that really caught my eye in the source material. With 3 tons of TNT worth of energy being released, my Hollywood-trained brain immediately pictures a massive fiery explosion visible from Earth. Like I'm picturing people standing in their backyards, pointing excitedly at a bright red flash on the moon.
Right, it's a great image, but the reality of physics in space paints a very different picture. Because we're in a vacuum, you obviously aren't going to get that lingering, billowing Hollywood fireball. Oxygen is required for combustion, so the only light produced is the initial instantaneous flash of heat and vaporized material.
How long does that last?
Scientists expect that flash to last less than a single second.
Less than a second. So blink and you miss it.
Literally. And to complicate the visibility even further, the rocket is scheduled to strike a part of the moon that is currently illuminated by the sun.
Oh, so it's hitting the bright side.
Yeah, you have a tiny split-second flash happening against a backdrop of incredibly bright sunlit lunar soil. The article makes it abundantly clear. An ordinary amateur telescope is not going to capture this. It will absolutely not be visible to the naked eye.
Wait, hold on. You're saying this crater is the size of a basketball court, and the flash lasts less than a second against a blindingly bright background. If I can't even see it with a decent telescope in my backyard, why on earth are professional astronomers mobilizing millions of dollars of equipment and linking up global observatory networks to look at what is essentially an invisible event?
Because they don't care about the flash. The real scientific prize, the thing they are desperate to capture, is the resulting dust cloud. When that kinetic shock wave hits, it's going to throw massive amounts of lunar soil, rock fragments, and shredded metal high into the space above the surface.
Ah, I see. And because the moon's gravity is only a sixth of ours, and there's no atmosphere to create drag, that dust behaves in a way that we simply cannot replicate on Earth.
Precisely. Computer simulations are predicting that the main curtain of this dust will rise 15 to 20 kilometers above the lunar surface. Now, on Earth, gravity and air pressure would pull a dust cloud back down in seconds. But on the moon, that debris is going to hang suspended in the vacuum for several minutes, just slowly argusing upward and outward.
20 kilometers is staggering. I mean, commercial airplanes on Earth cap out around 10 kilometers. So this main curtain of dirt is going twice as high as a 747 cruises.
It is huge, and the article notes that in an optimistic scenario, a narrower jet of fast-moving particles, which is the material ejected from the absolute center of the impact, could shoot up to 75 or even 100 kilometers high.
100 kilometers.
Yeah, and because the impact site, the Einstein crater, is near the edge of the moon's visible disk from our perspective, part of this massive towering dust cloud might actually extend beyond the illuminated edge of the moon.
Meaning it would be silhouetted directly against the pitch-black background of space.
Exactly. And that high-contrast silhouette might just make it visible to high-powered telescopes.
Yeah.
The eastern United States, Canada, and parts of South America are going to have the optimal viewing angle, as it will be nighttime there, and the moon will be positioned high in the sky, which minimizes the atmospheric distortion from Earth.
Okay, I understand the visual spectacle of a 100-kilometer dust plume. That sounds amazing. But what is the actual scientific value here? How does measuring the height of a dust plume tell scientists anything useful about the moon?
Think of it as a massive, free core sample of the lunar subsurface.
Like drilling down, but without the drill.
Right. When you observe that dust plume using spectrometry, you are analyzing the specific wavelengths of light reflecting off the particles in the cloud. Different chemical elements absorb and reflect light differently. So by studying the light signature of that suspended dust, scientists can determine the exact composition of the bedrock that was buried 5 meters underground.
Oh, wow. Stuff that hasn't seen the light of day in forever.
Billions of years, yeah. Areas that haven't been exposed to the surface environment, it tells them about the density, the mineral makeup, and the geological history of that specific region.
And the ground-based telescopes aren't the only ones trying to catch this spectral signature. The article mentions 2 specific spacecraft that are getting front-row seats to this collision. NASA's Lunar Reconnaissance Orbiter is tasked with taking before and after photos to locate the new crater and measure its exact dimensions. But the one that really gets my heart racing is South Korea's Denuri spacecraft.
Oh, the timing regarding the Denuri spacecraft is one of the most incredible orbital coincidences of this whole event.
According to the trajectory data, Denuri is going to fly past the exact impact zone, just a few kilometers away, only 2 minutes before the rocket smashes into it.
Oh.
2 minutes. It's like a pedestrian walking casually through an intersection 120 seconds before a high-speed car chase blows through and totals a building.
It is incredibly close timing when you consider the orbital speeds these objects are traveling at. It really highlights why this is such a unique scientific opportunity. Now, to be fair, the scientific community has deliberately crashed things into the moon before.
Right, like during the Apollo program.
Yeah, NASA purposefully crashed empty lunar modules to create seismic waves, basically using them like tuning forks to test the interior structure of the moon.
And in 2009, they crashed the LCRS spacecraft into the lunar South Pole, specifically to kick up dirt to look for water ice.
Exactly. But those were highly controlled, meticulously planned events with optimal viewing conditions. Wednesday's event is entirely different. This is only the second known time in history that a piece of space debris has accidentally crashed into the moon.
Wait, only the second. What was the first?
The first happened in March 2022. It was a spent rocket body, which is generally attributed to a Chinese mission. However, that piece of debris hit the far side of the moon.
So we couldn't even see it.
Right, it was completely hidden from Earth's view. We couldn't observe the impact or the dust plume. We only found the resulting crater months later through satellite photos. So Wednesday's crash is the very first time in human history that we get to watch an accidental lunar impact unfold in real time.
Which is an undeniable thrill for the scientists. I mean, they get a massive, unscripted physics experiment to study how lunar regolith behaves under kinetic stress. But, as I read further into this Jerusalem Post article, the tone definitely shifts. While the science is fascinating, the underlying reason this is happening points to a growing and honestly concerning reality about how we operate in space. Because this crash didn't have to happen.
No, it didn't. The space experts quoted in the piece point out that this is an entirely preventable error in space traffic management. After the Falcon 9 dropped off its landers, SpaceX had options. They could have adjusted the rocket's trajectory.
How so?
Well, a short burn using the last remaining bit of fuel could have pushed the upper stage into a stable heliocentric orbit, an orbit around the sun where it would just float harmlessly for millennia.
But they didn't do that. And for decades, the aerospace industry operated under what they call the big sky theory. Basically, the area between the Earth and the Moon is incredibly vast. If you leave a dead rocket up there, the odds of it hitting anything important were practically zero. It was out of sight, out of mind.
But the paradigm has drastically shifted. We are no longer operating in an empty void.
Here's where it gets really interesting. I want you to think about cislunar space, not as an empty ocean, but as a newly opened superhighway. For a long time, there was maybe one car on it a year. But now we have the US, China, India, and a myriad of commercial companies like SpaceX, Firefly, and iSpace, all sending traffic up this highway. It is rapidly filling with vehicles. But there are absolutely no traffic laws, no designated lanes, no speed limits, and crucially, no street sweepers.
It's a great analogy. We are actively treating cislunar space as a dumping ground. Leaving these spent stages in unstable orbits is the equivalent of leaving a broken-down car in the middle of a dark highway and just hoping no one hits it.
And while Wednesday's crash poses no danger to Earth and no danger to people right now, it is a massive warning sign. Because as this article points out, the US and China aren't just sending small robotic landers anymore. They are actively planning crewed missions. They are designing long-term infrastructure, habitats, solar arrays, and fuel depots on the lunar surface.
If we connect this to the bigger picture, you start to see why astronomers and aerospace engineers are so obsessed with measuring that dust cloud and debris spread on Wednesday. It isn't just for academic curiosity regarding the bedrock. It is critical safety data for human survival.
I'd imagine if you're designing a lunar habitat, you are primarily worried about micrometeoroids like tiny grains of space dust, not a 4-ton chunk of a Falcon 9 hitting the ground nearby at Mach 7. So how does tracking this specific dust cloud change how we build a moon base?
Well, think about the physics of the shrapnel. A 4-ton object hits the moon, and because of the low gravity and lack of atmosphere to provide friction, shredded aluminum and jagged rock fragments are thrown outward at ballistic speeds. Scientists need to calculate the ballistic coefficients of that debris. If a chunk of metal is thrown outward, how far does it travel before it hits the ground? 50 kilometers. 100.
Right. Think about the car parked in your driveway right now. On Earth, if there's a violent car crash 50 miles away from your house, it means absolutely nothing to you. The air resistance and gravity stop the debris within a few hundred feet. But on the moon, a crash 50 miles away means deadly shrapnel is flying straight at your living room window with zero air resistance to slow it down.
Exactly. And that shrapnel, even a piece of jagged metal the size of a coin traveling at a kilometer per second, will punch straight through standard structural materials. By tracking the exact spread of the debris from Wednesday's crash, engineers can build accurate safety models. It dictates the thickness of the Kevlar-like shielding required for future habitats, like NASA's planned Artemis Base Camp. They need to know exactly how far the danger zone extends when a multi-ton object impacts the surface.
Because right now, the lunar landfill is just growing. We have no centralized system for cleaning it up, no mandate for tracking it all accurately, and no authority enforcing collision avoidance. We are just relying on the fact that space is big, basically hoping our shiny new habitats don't get caught in the crossfire.
And relying on the size of space is a strategy that historically only works until it suddenly, catastrophically doesn't.
So what does this all mean? We pull all these threads together, and the picture is pretty stark. On one hand, this coming Wednesday, we're going to witness an unprecedented scientific windfall. A massive piece of a SpaceX rocket is going to slam into the moon, instantly converting its kinetic energy into a 3-ton TNT equivalent shockwave. It's going to kick up a majestic plume of lunar dust that might reach the very edge of space, giving astronomers a real-time, free core sample of lunar geology.
Yeah, the spectral data alone will keep researchers busy for years.
But, on the other hand, it is a glaring wake-up call, disguised as a cool experiment. We are treating the moon's orbit like an unregulated frontier. The chaotic trajectory that this rocket has been riding for 18 months is a symptom of a larger disease. We are filling the Earth-Moon superhighway with high-speed trash, and we honestly don't have a cohesive plan for how to handle it.
This raises an important question and a very provocative thought that the entire aerospace industry needs to start considering immediately. We are entering an era of immense lunar development. The US, China, and massively funded private corporations are racing to build permanent infrastructure on the moon.
Real estate is actively being claimed.
Right. So what happens 10 years from now? Let's say a commercial lunar habitat is fully operational or a sovereign nation's fuel depot is up and running. A dead, unregulated piece of space junk from a rival nation or perhaps a bankrupt private company comes hurtling out of an unstable orbit and completely destroys that multi-billion-dollar facility.
Oh, wow. That's a terrifying scenario.
It is. And the Outer Space Treaty of 1967 is woefully inadequate for this scenario. There are no salvage rights defined, and there is no comprehensive insurance framework for lunar surface damage.
So an accidental shrapnel from an 18-month-old rocket punches through a habitat and, God forbid, kills an astronaut who is financially and legally liable.
Exactly. Who pays the insurance claim on a destroyed lunar base? We are rushing headlong into a future of interstellar real estate development, and the legal framework for liability, traffic management, and trash removal remains almost completely unanswered.
It is the ultimate Wild West. And the tumbleweeds are made of titanium, moving at 7 times the speed of sound. That is definitely something to think about the next time you step outside, look up at the night sky, and see that pristine, silent moon hanging in the dark. Because it might be silent to you down here, but the traffic up there is getting incredibly complicated. Thank you so much for joining us on this deep dive. We'll catch you on the next one.